A super El Niño could be in store for 2026. As temperatures heat up again in the Pacific Ocean, some scientists are predicting that we could be in store for one of the strongest El Niño events of the last 140 years. If true, this could lead to more hurricanes in Asia, more droughts in South America, Australia and India, heat waves in the US, and push the world towards record-high temperatures. But what even is El Niño? Why is it forming again in the Pacific? And how sure are we that the next El Niño will be strong enough to warrant a super El Niño? Let's get into it. It all starts up here with the wind. Normally, these trade winds that blow over the Pacific go from east to west, pushing water from South America across the ocean to Asia. This water moves like a conveyor belt, so as the surface water moves west, deeper water moves to the surface to replace it. This process, known as upwelling, cools down the ocean and brings nutrients to the surface where plankton can grow, supporting rich ecosystems and massive fisheries. The water moving west gets warmer and warmer as it spends more time in the sun, eventually reaching Indonesia and spreading out. This colder east and warmer west Pacific Ocean is the typical or neutral state, leading to predictable temperatures, weather patterns and ocean circulation. Sometimes these winds get even stronger, and that's a La Niña year. This makes the eastern Pacific extra cold with extra upwelling, but then shoves even more warm water to the western Pacific, heating it up. And since warm water evaporates more quickly, these La Niña years cause warmer weather conditions around India, Australia, and even as far as East Africa. But of course, the eastern side, with its cooler water, leads to less evaporation and drier, colder conditions for places like Chile, Argentina, and the southwest United States. Also, since there's extra cold water reaching the surface, La Niña years tend to cool the entire planet down, stabilizing things against a rapidly warming climate. But all that changes when the winds start to weaken. The ocean, like many of us, goes through phases. Mom, it was never a phase. Where small changes can kickstart a powerful feedback loop. At some points, the trade winds blowing east to west start to weaken. This causes less cold water to upwell, making the Pacific warm up faster. This warmer surface ocean further weakens the trade winds, causing the ocean to warm more, reinforcing this phase that we know as El Niño. Eventually, it can get to a point where the trade winds stop altogether or even blow backwards, pushing warm water from west to east. This shifts a lot of this warm water away from Asia and closer to the Americas, usually causing droughts across India, Indonesia, and Australia. Over the Pacific, this excess heat in the middle causes much stronger hurricanes to form, affecting many of the Pacific island nations. And on the other side of the world, it dramatically shifts rainfall patterns, causing more floods in the US, southern Brazil and Peru, and longer droughts in Central America and northern Brazil. Also, by stopping the upwelling, the water in the eastern Pacific is warmer with fewer nutrients in it, hurting fisheries. For example, in the Peruvian anchoveta fishery, one of the largest fisheries in the world, yields dropped nearly 80% during the 1997 to 98 El Niño. El Niño also impacts fisheries in North America, causing species to migrate much further north to avoid warmer waters. However, sometimes migration is not possible, and El Niño heat waves have led to mass die-offs in species like sockeye salmon in the Pacific Northwest. While not every fishery in the Pacific is harmed by El Niño, the ecosystem disruption on top of the warming caused by climate change can make it hard to predict the outcome of these years. To monitor the state of the Pacific, organizations like the National Oceanic and Atmospheric Administration, or NOAA, have buoys and satellites monitoring the surface temperature. Using a specific region of the ocean known as the Niño 3.4 region, temperatures are recorded and averaged over 3 months to create the Oceanic Niño Index, or ONI. If the ONI is 0.5 degrees Celsius warmer than normal, it's an El Niño year, and if the ONI is 0.5 degrees Celsius cooler than normal, it's a La Niña year. There are also tiers to the ONI, with moderate, strong, and very strong El Niños occurring at 1, 1.5, and 2 degrees C of warming. As of writing this, the ONI was around 0.2 degrees C cooler than usual, meaning that the Pacific is in a neutral state between El Niño and La Niña. So then why are people freaking out about a super El Niño? Early in April of 2026, a rare triplet of tropical storms began to form over the western Pacific. While none of these 3 storms was particularly strong, all 3 happening at once seriously messed with the trade winds. The counterclockwise spin of the northern storm and the clockwise spin of the southern storms caused strong gusts of wind to blow backwards against the Pacific trade winds. This stalled the water that normally moves west, causing a bunch of warmer water to pile up just under the surface. Most scientists and climate models are now predicting that we will be in a moderate to strong El Niño by as early as mid-June. And roughly 50% of the models used by the European Centre for Medium-Range Weather Forecasts are predicting that we will see at least 2.5 degrees Celsius of warming by October, setting the stage for a super El Niño event. NOAA has also forecasted a 61% chance of El Niño by the summer and a 25% chance of a super El Niño by the end of the year. The disasters brought by this have the potential to be record-breaking, especially as Earth's temperature continues to climb. When disturbances like El Niño are this strong, they tend to leave lasting impressions on the ecosystems they affect. Coral reefs, kelp forests, and fisheries in the Pacific may take years to recover, even after all is said and done. It is not a guarantee that 2026 will be a super El Niño, or even a particularly strong one, but it has the makings of one, and climate scientists are watching it very closely. With more advanced models and observations, we're able to peer into the future with more clarity than ever before, giving people like farmers, fishers, and water workers critical time to prepare. The funding of programs like NOAA has never been more important as the climate changes, and they will put their expertise and resources to good use, tracking what could be one of the strongest El Niños in history. Thanks for sticking around to the end. As always, all the sources are linked down below. If you learned something from this, enjoyed this, or just want to see more climate science on YouTube, make sure to like, comment, and subscribe.